Hello, my name is Diana Malloy and I'm representing Atego. Today I'll be giving you a demonstration of one of the iFest integration platforms, Atego Workbench. It supports the SELEX Galileo toolchain. Multiple partners have been involved in bringing this prototype together. Atego have provided Atego Workbench, an existing product with additions to support the iFest services that extend OSLC. The industrial case has been defined and worked on by SELEX Galileo. The iFest adapters, services and tools are provided by Opportunity, Visure and Axelica. The key features demonstrated include requirement elicitation, hardware-software co-design, automatic code generation and traceability across all tools. Atego Workbench is an existing tool updated to support the iFest specifications which extend the OSLC approach. It provides a tool-agnostic, intuitive user interface for tools running on different servers distributed over the Internet. It gives easy access to engineers and managers alike to multiple cross-domain functionalities supporting all stages of the product lifecycle, with savings to be made on training and knowledge transfer. It provides management and control of complex configurations comprising of heterogeneous and interrelated artifacts. It provides the efficient automation of repetitive tasks to enforce tool configuration at project level and greater use of code generation and high-level synthesis. The SELEX Galileo industrial case uses a digital receiver for the detection and classification of radar signals. It has a streaming architecture with the individual subsystems indicated in the diagram. The two principal implementation aims are 1. To provide a platform-independent design with efficient routes to implementation code, and 2. To provide flexible partitioning between hardware and software. This logical view shows the integrated tools in this toolchain. It includes IRQA for requirements capture and analysis, Artisan Studio for UML modeling and design, Falcon ML for model-based C and VHDL code generation, Blueprint Automation Server for automating Falcon ML, and Blueprint Configuration Management Server for the storage of source files. Atego Workbench is an integration platform with lifecycle management supporting a product through the requirements and analysis, design and implementation, and verification and validation phases of the project. It provides cross-domain capabilities to support version control, change control, baselines, document generation and traceability in a tool-agnostic manner. Under iFest, Atego Workbench has been extended to support tool integration using the iFest specifications. Atego Workbench provides two types of iFest integration, and these will be illustrated during the demonstration. SELEX Galileo uses the Visure IRQA requirements tool to capture and analyze requirements. Over the lifetime of a project, SELEX Galileo would make use of multiple iterations of the requirements. Each of the SELEX Galileo subsystems maps to a block in IRQA. Each block maps to a requirement collection resource exposed by the iFest IRQA adapter. Each block has a set of requirements and represents a subsystem. Using IRQA, the requirements engineer creates a new requirement. The description is added and the requirement is checked in. A baseline is now created. When the requirements engineer is ready to share his updates with other project users, he must baseline a set of requirements. Only requirement collections and requirements that have been baselined will be exposed through the iFest IRQA adapter. Now that the set of requirements is complete and baselined, the requirements engineer can make this information available in Atego Workbench by creating an entity. The entity is just a reference to a set of requirements. The actual data is not copied to Atego Workbench. This introduces the integration with the Visio IRQA. Atego Workbench relies on the Delegated User Interface, or UI, provided by the Visio IRQA adapter to allow the user to select IFEST-defined resources. This is the Atego Workbench now, and I will create an entity for the functional requirement using the Visio IRQA adapter. Select the generic OSLC option from the integrated tool list and the IRQA RM option from the list of currently available IFEST services. Atego Workbench then makes a request to the IRQA adapter to show its delegated UI to display the baseline requirements directly from the IRQA database. The delegated UI has 3 panes. The first shows a list of baselines within IRQA. Once the baseline is selected, the second pane is populated with the requirement collections within that baseline. Having selected a requirement collection, the third pane is populated with a summary of all the requirements within the collection. The requirement collection is selected, and the delegated UI returns the URI of the requirement collection to Atego Workbench. The URI is used to create the entity. This process is repeated to create the commentary entity. The demonstration moves to another phase of the project, the design. Atego Workbench has an existing integration with Artisan Studio, using an alternative API. This integration is not compliant with the IFEST specification, but it does expose the individual elements of a UML model, allowing the user to trace to or from Artisan Studio elements to those resources exposed by the IFEST adapters. An Artisan Studio entity is used to represent the hardware-software co-design for the digital receiver subsystems. The system class diagram shows the classes that make up the system. The interface diagram defines the interfaces in the system, showing the provided and required interfaces. The DRX diagram shows the subsystem allocation, the sequence of classes, and the way that they have been allocated to FPGA and CPU using the Mate profile. IFEST uses the OMG XMI as a standard interchange format for the UML model. The XMI is generated from the Studio model, stored and referenced by Atego Workbench entity. It is later processed by FalconML to produce both the VHDL and C code. The next stage of the toolchain is back in Atego Workbench, preparing entities for tracing, automation and other cross-domain functionality. This is a small generic lifecycle process that Atego Workbench enforces around each entity. It is completely independent of the tool used to create the entity. Select the Complete Work option on the requirement entity created earlier. Using the URI, Atego Workbench queries the IFEST adapter, requesting a common set of IFEST properties for each resource. This data is stored to provide a read-only overview of the requirement collection without requerying the IFEST adapter. Some IFEST specifications support a standard interchange format. If implemented, Atego Workbench requests and stores this data. Atego Workbench Viewer can then display both the read-only overview and the interchange format, which is then used for tracing and IFEST tool-agnostic change analysis. The final step is to complete the review. For demonstration purposes, a quick self-review is sufficient. The review is completed and the entity is now ready for reuse. The next step is to take the OMG XMI file generated from the digital receiver design and automatically generate C and VHDL code files. This is compliant with the standard interchange format as defined in the IFEST specification. The Blueprint Automation Server implements the IFEST automation specification to provide a generic solution for any command line tool. IFEST is able to demonstrate how Atego Workbench integrates with the automation server to manage the input and output parameters over time and control the execution of command line tools. Each command line tool requires an IFEST plugin. For this demonstration, the FalconML code generator is used. Let's take a closer look. Axilica FalconML is a high-level synthesis tool that enables the hardware-software co-design in UML. It translates an untimed UML C++ model to target languages suitable for FPGA implementation. It is a command-line tool which takes two files as input, the XMI representation of the design and the XML configuration data. The configuration file contains synthesis directives for FalconML. It generates a number of output files. Let's go back to Atego Workbench to see how this is achieved. There is an entity for the design in Artisan Studio. I have already created an entity for the XMI exported from the model, and one for containing the configuration file. I want to store the results of the automation server, of the automation in the Blueprint CMS server. So I create another entity using the CMS service. The delegated UI is used to determine where the results will be stored. I navigate through the configurations to select the appropriate directory version. Select to create the entity. We bring all this together by creating an automation entity. This is used to repeatedly execute FalconML. Select the automation service. This causes the delegated UI to be displayed showing the existing automation plans. Select the FalconML plan. Note how the plan gives details of the required input and output parameters. Using the input resource pane, I add the XMI, the XML, and the results file to the automation entity. This relationship is maintained throughout the project, with options to update the version of the inputs over time. By selecting to complete work, Atego Workbench makes an automation request to the automation server to execute the automation plan with parameters. Once the automation task has been completed, the automation results can be queried to identify success or failure of the request. This section is dedicated to demonstrating how Atego Workbench enables cross-domain traceability between all entities in a completely tool-agnostic manner. Before tracing, there must be a trace-target relationship between the two entities. I'm going to add a trace target in preparation for tracing from the commentary entity to the functional requirement entity, both IRQ entities created earlier in the demonstration. Select to create an element-to-element trace. This displays the Create Trace pane. The requirements of the commentary entity are displayed in the delegated UI, and the IRQA repository is being dynamically queried using the IFEST interface. The IFEST resources show just enough information to allow the user to select the current requirement, providing an efficient integration by keeping the exchange of information between tools to a minimum. The reviewed, read-only functional requirements are displayed in the Atego Workbench viewer. An element from each is selected, and the relationship between the two is created from the Create Trace pane. This is repeated to create traces from the design back to the requirements. The trace target is created, an element is selected from Artisan Studio, and a functional requirement from the viewer. To conclude this demonstration, the Trace tool is used to make traces from the automatically generated result files back to the design in Artisan Studio. And finally, the user wants to generate reports on the traces. From any entity in the project, the user can select the Traceability viewer to report on traces to and from that entity. By selecting the Functional Requirements entity, traces from the functional requirements created in IRQA to the design in Artisan Studio to the code results stored in the Blueprint CMS are shown. When any trace is selected, the Atego Workbench viewer shows the entity with the element highlighted. The traces are color-coded to signify the type of trace, satisfaction, verification, evidence, etc. Attention is immediately drawn to those elements that are not traced or where the level of tracing is inconsistent. By the end of the IFEST project, additional tools will be available for the SELEX industrial case to use. There will be an IFEST MATLAB Simulink adapter implementing the IFEST Simulink specification, and a number of additional tools using the automation server, which include Altera Quartus, Xilinx, Divine, and Model Sim. Atego Workbench is an integration platform providing a client interface to access multiple IFEST adapters and service providers. By accessing the linked data provided by the IFEST tool integrations, Atego Workbench is able to provide tool-agnostic support for traceability, report and analysis, configuration management and document generation. The demonstration today has shown how Atego Workbench supports the SELEX Galileo toolchain for requirements capture and analysis, modelling, automatic code generation, and the management of traceability and versions during the life cycle of the product. Atego Workbench, a tool integration platform using IFEST specifications.